All right, so we're going to talk about the unit circle today. Remember, the quiz is Thursday for the unit circle only, okay? Okay, the quiz is going to look exactly like maybe 6B. Okay, but today we're going to talk about how you develop all that. So don't start filling it in, please. All right. And then we have a quiz over the rest of what we've been doing so far this semester on Friday. All right, first warm-up problem of the day. What's going on here? Linear speed or linear velocity, okay, is how fast you are turning if you're sitting in that seat, and it says in miles per hour. On your sheet, there is a formula that says linear velocity equals angular velocity times radius. Okay, we need to find angular velocity. Angular velocity is how fast it's turning. What is it telling us? 2 revolutions per minute. Is that an angular velocity? No, not until we turn it into what? Radians. So 1 revolution is 2 pi radians. Everybody okay with that dimensional analysis? So we get 4 pi radians per minute. Okay? This is our angular velocity. Then we need to multiply that by a radius. What's the radius up here, guys? Okay. Diameter means all the way across. Radius is half of that. We're good? Okay. Okay. What does it ask for, though? In the end, we want miles per hour. Okay. So right now we have minutes in the denominator. We need that to cancel. So minutes needs to go up here, and we want hours. 60 minutes is 1 hour. Now the minutes label's gone, and we have per hour. Feet to miles. Yes. 5,280 feet is 1 mile. Okay. If you need that, I would probably give it to you. Yes. Okay. All of this stuff on the top gets multiplied, and then we divide by 5,280. Type. See what you get. I got 2.1. Anybody get that? Ferris wheel doesn't really go very fast, right? Okay. All right. Another review, warm up. Anybody have questions still on this one? What? Okay. Let me see if I can make these a little bit bigger. They look kind of tiny because you don't have them either. Okay. Do you remember your special right triangles? Well, we need to today. 45, 45, 90 is x, and s square roots of 2. The 30, 60, 90, okay, is short leg or x. Long leg is the short leg times square root of 3, or x square root of 3. The hypotenuse is 2 times the short leg. Yes? No? Maybe? Okay. So on this little jobby, we need a 7. And on this one, 4, and nothing too tricky, right? All right, this is a 5. X is 10. 5 square roots of 3. Okay, across from the 30 is 3 square roots of 3. You'd have to double that and put it where? That's the short leg. So you'd double it and put it here. And then you would multiply it by, multiply the short leg by another square root of 3, which would become square root of 3 times square root of 3 is 3, times that other 3 is 9. Now that doesn't really look right, but if you take and type 6 square roots of 3 on your calculator, it's more than 9, okay? All right. We found trig values for acute angles using right triangles in the past. We're going to continue to do that, but we're going to use the right angle that's on the unit circle, the right triangle. So we have to know something about reference angles. Reference angles are really, really, really important, okay? These definitions are also important, okay? The definitions of the 6 trig functions are not just opposite over hypotenuse, okay, or adjacent over hypotenuse. How many of you have these memorized? Okay, the sine is y, the cosine is x, and those are both over the radius because the radius is the hypotenuse, yes? Okay, and tangent is y over x. If you know those, then you should be able to flip them over and do this. All right, so this is off your notes. Again, find it. Am I out of order or is this at the top? Okay, so make sure you have these memorized. All right, here's my little bow tie for you. The reference angle, anytime you tell me I'm going to start measuring here and I'm going to stop measuring over here, okay? Anytime you do that, the reference angle is the angle to the nearest x-axis, not the y-axis, okay? So it's either to 0 or 180, right? Or 360. So if I had 123 degrees, I would need this angle with the x-axis, which would be 180 minus 123, or 57. Did I do that right? Would be the reference angle. Okay, if I'm down into this quadrant, say 200, what's the reference angle? It's the angle back to the x, so it's 20, yes? If you're into this quadrant, what if you're only 295 degrees? Well, this is 270, so we went 25 past. Is it 25? No, it's the angle to the x-axis here. How can we find that? Is it 65? Does this all sound familiar? We okay with this? Because this is really important. It's much more painful when it's in radians, right? So you can always convert back and forth. My brain works better in degrees as well. Right. The other thing you have to then know is about the signs. Okay, in the first quadrant, everything's positive, so all of the functions are positive, right? X and Y are positive, so everything is positive. In this quadrant over here, quadrant 2, X is negative and Y is positive, right? X is which function? Do you remember those definitions at all? X is cosine. So cosine is negative. And what else has an X in it? Tangent is Y over X, right? So tangent is also negative, as are their reciprocals. Okay? So sine is the only thing that's positive. Down in this quadrant, both X and Y are negative. So sine is negative cosine is negative, but when you put y over x, you get a positive. So the tangent is positive here. All right, down here, y is negative, but x is positive because you went to the right. So which one's positive? Cosine, because it's x. Okay? Now, they were all positive here. Most students remember it using that. They go all sine, tangent, cosine. Okay? Some things you can use to remember that. All students take calculus, is what most teachers teach. Some like to just remember it spells X, but if you do that, you're going the other direction. Yeah, and then you might get your quadrants mixed up. So if you go around this way, okay, all students take calculus, or a sorry teacher choked, I don't know. I'm just making something up on the fly here. All right. Yeah, if you do, it's ACTs, though, then you're going the opposite direction. So whatever helps you remember it. But what do those letters stand for again? It doesn't do you any good if you don't know what it stands for. What does the S in quadrant 2 stand for? Sine is what? Sine is the only one that's positive, and it's reciprocal, which would be cosecant. Do you get it? Everybody okay? All right. So we covered reference angles. Okay. This is how to find them. I don't even want to think about this. I just want to think about finding it to the nearest x-axis, right? I don't want to memorize all those rules. Okay. The quadrantal angles, we're going to use the ordered pairs. Okay. This is radius 0, 0, radius, negative radius 0, and 0, negative radius for all those. We're going to just use on the unit circle the coordinate 1, 0, etc. All right, sketch each angle and find its reference angle. So real quick, what quadrant would we stop in for 330? So you'd draw your little arc here showing they went all the way around here to quadrant 4 and you stopped. And then it says find the reference angle, okay? So initial side here, terminal side here. The reference angle, remember, is this angle. For reference angle, they often use alpha. You can use theta, I don't care, but it's this angle the rest of the way here. If this is 330, what's the rest of the way to the x-axis here? Okay, now we have two choices. If you know what quadrants this is in, actually, if it's pi over 4 of any kind, the reference angle is pi over 4. But do some of you at least know what pi over 4 is as a degree? Okay, guys, pi, wait a minute. Pi is how many degrees? 180. So you cut it in half and you get 90. You cut it in half again and you get 45. So a pi over 4, is everybody paying attention? Pi over 4 is 45. If I start going negative, 45 degrees, 45 degrees, 45 degrees, I'm going to wind up right there. Everybody good? So that's negative 3 pi over 4. Okay. The reference angle is here. If we were doing some fancy schmancy stuff, okay, we would have to say, like, if it was degrees, we'd go, this is 180 and this is negative 135. So we'd go, the difference between those is 45, right? So if we were doing it radians, we'd have to do pi and 3 pi over 4. The difference is pi over 4. Okay, it's 45 or pi over 4. On this, when it asks you for a reference angle, you need to answer in the kind of measure they give you. Yes. Radians means answer in radians, degrees in degrees. Okay, so this isn't even reduced. If I reduce this, it's 3 pi over 2, right? Now, if pi is 180, guys, I'm trying to help you do some mental math here. If pi is 180, okay, divide that by 2 and you get what? 90 times 3 is 270. So this angle is really right here. Reference angle doesn't have one. Okay, it's called a quadrantal angle. A reference angle, by definition, is always positive angle less than 90, okay? We're still doing reference angles here? Do we need to do all these? Okay, I'll do number 4 real quick. Is this more than 2 pi? 12/6 would be 2, right? Okay, if I think of this as 180, guys, 180 divided by 6 is 30. Everybody okay? 30 times 11. 330. So it's right over here. 11 pi over 6 is the same as 330. So this in degrees would be what? 30 degrees, which is, anybody know? Pi over 6, okay? You'd have to go, this is 2 pi minus 11 pi over 6, or 12 pi over 6 minus 11 pi over 6. I would have just changed it to degrees in my head. All right, 165, real fast. What quadrant are we stopping in? 2, because this is 180. And then the reference angle is this angle here, which is the difference between 180 and 165, which is 15. Okay, negative 5 pi over 9. I think I have to change that to degrees. Okay, pi is 180. So 9 divided by 180 is 20 times 5. Negative 100 degrees. So it's here. So the rest of the way to 180, or negative 180, or positive. If we went negative 100, what's this angle here? 80 in degrees, but we need it in. So we got to do a pi over 180. 8/18 reduces to 4/9. And some of you could have just done that. Pi minus 5/9 is 4/9. Okay. But that's the reference angle. I think I mostly put degree reference angles on the quiz. Anybody lost? All right. This is totally review. I don't want to spend a lot of time on this because this is the same as we just did this. We did it by drawing though, right? If I go 9 to the left and up 12, this is negative 9 and this is positive 12. We're actually talking about this angle, but we use this reference triangle. So then we just do Pythagorean theorem. Everybody good? And then we can find all the functions. Everybody feel okay with that? The other way to do it, guys, is to just call this x is negative 9, y is 12, and you can find r by this formula. Okay, turns out to be 15. R is always positive. The hypotenuse is always positive. And then you could use your x, y, r definitions. I just usually draw the triangle. All right, so what quadrant are we going to do for number 7? Two to the right, down 5, yes? Pythagorean theorem, anybody? Can use R, I used H for hypotenuse, sorry. What do we get? 25 and 4 is square root of 29 right there. That's a lovely number. No decimals, guys. Everything's got to be exact. So the sine of this angle that took us all the way around to here, we're using the reference angle in here. Sine is y over r, or opposite over hypotenuse. So it's -5 over square root of 29, which becomes what? -5 square roots of 29 over 29. Okay, cosecant flips that over. What was it before we rationalized it? You want to flip this one over. Square root of 29 over -5. Okay, in this quadrant, what should be happening for sines? All students take calculus. The only one that should turn out positive is the cosine and its reciprocal. So cosine is adjacent over hypotenuse, or 2 over square root of 29, which is 2 square roots of 29. I don't know what just happened. Two square roots 29 over 29. If we flip it over, we get the secant, which is this guy flipped, square root of 29 over 2. All right, and tangent is y over x, or opposite over adjacent. We could have found the tangent from this original value, -5 over 2, so the cotangent is -2/5. Doesn't matter if the negative's top or bottom. Questions? Okay, I'm not going to do number 8. We're good? All right. These are quadrantal angles. So I want to talk about these because we can just use the ordered pairs. If we use a radius of 1, this distance is 1, what is that ordered pair right there? It went across 0 and down -1, yes? Okay, so cosine is x, y, what is it? They're alphabetical order, guys. Cosine, sine, x, y. So cosine is x. So this is x over r. The radius is just 1. So it's 0 over 1, or just 0. You can just use x, the ordered pair, the x right here. Okay? Pi over 2. Pi over 2 is right here. The radius to that spot is 1, but the ordered pair is what? 0, 1. Okay. Cosecant means you find what first? The sine. Okay? The sine at pi over 2 is the y value, so it's 1. Okay? But cosecant means we do the reciprocal. What happens when you flip 1 over? You still get 1, right? Okay? Cotangent, -90. Well, -90 is back down here. Cotangent, though, is what? Okay, what's definition of tangent? This is why you got to know these x, y, r definitions, because there's no little triangle right there. Okay? Tangent, guys, is y over x. So cotangent is x over y. So if I put 0 over -1, Is that undefined or is it 0? 0 over -1 is 0. It's only undefined if the 0 is underneath. Underneath, the 0's underneath, it's undefined. All right, division by 0 is what's undefined, not dividing by -1. All right, unit circle stuff. If you know these relationships, we're going to talk about the unit circle. I don't want you using your pink sheet right now. I want you thinking about 5 pi over 3, okay? 5 pi over 3. I would like you to be able to do some mental math here. If pi is 180, what's 180 divided by 3? 60. So we have 5 of those, which is 300, okay? You can do this. I'm just trying to shorten it up a little bit. This goes in here 6 times, that's 300. Okay, so we run around 300 degrees. What's the reference then? 60. So if you want to label this, you get x, x squared root of 3, and 2x. Does that sound familiar from your 30, 60, 90? All right, and what's the sign? I don't even have numbers on here, and I can still do this, okay? Because the sign is opposite over hypotenuse. Would it be easier with numbers for most of you? So let's call this 1. 1 square root of 3, and 2 times 1. In a minute, we're going to talk about changing that radius to 1. But which of those is negative before we get too far? You went right and down, so this one is negative. All right, so now what's the sign? You can do y over r or opposite over hypotenuse. You get negative square root of 3 over 2, yes? Eventually, you're just going to use your pink sheet, yes, but I'm trying to help you see where these came from. All right, cosecant of 210. 210 is into this quadrant by how much? 30 degrees, okay? Using those same numbers, short leg is 1. What else am I going to do? 2 goes where? Okay, square root of 3. Which ones are negative in that quadrant? I went left and down. The radius is always positive. Cosecant, okay? A lot of stuff you got to memorize here, guys. Sine is opposite over hypotenuse, so we need hypotenuse over opposite from this reference angle, which would be 2 over -1. So this answer is -2. All right, one more, -315. If I subtract from 360, I get 45. Uh-oh. Not the same pattern at all, right? This time it's 1, 1, and square root of 2. If I make x 1, everybody okay? So cosine, adjacent over hypotenuse, which is square root of 2 over 2. Everybody good? All right, let's talk about using the unit circle then. All right, when we get to the unit circle and we understand and have developed the unit circle, we're going to remember the first is the cosine. X is cosine, y is sine. Okay, how do you get the tangent again? Y over x. Yes, you have to know y over x. All right, I want you to take out, well, let me make sure I don't have something else I want to do. No, I don't want to go straight to that. I want to go, okay. We'll talk about this left-hand method in just a second. That's just to help you memorize it. You don't have this, okay? You have the full unit circle. You can fill it in on the full unit circle if you want. But I just want to talk about degrees for a minute. 30 is this width right here. So where's the next time we hit a multiple of 30? Yeah, we skipped this guy, right? We go 30, 60, 90. What's another 30? And another 30. And another 30. And another 30. And another 30. 240, right? And another 30. And another 30. And another 30. And this would be 360 or 0. Okay. I skipped the in-between ones because this width is only 15, so 30 and 15 makes this. Now, if you add another 45, you land here at 90, yes? Another 45 added onto 90 is 135, another 45 is 180, another 45 is 225. Add 45 and you get 270. Add 45 and you get 315. Add 45 and you get 360. Everybody okay with the degrees? Okay. Now we're going to talk about how I do the radians quickly. Okay. This is a pi over 6. This distance right here. So guess this is 2 of those. This is 3 of those. This is 4 of those. This is 5 of those. 6 of those. 7 of those. 8 of those. 9 of those. 10 of those. And 11 of those. How many of those reduce? A lot of them, right? This is 1 pi over 6. This one reduces to 1 pi over 3. What's 3/6? Pi over 2. 4/6 is 2/3. 5/6 doesn't reduce. 6/6 is 1. 7/6 doesn't reduce. 8/6 is 4/3. 9/6 is 3/2. 10/6 is 5/3. 11/6 doesn't reduce, and 12/6 is 2. Okay. But I only had to memorize one thing, right? And I got all those filled in. Anybody know what pi over 4 is, or 45 is? It's pi over 4. That was pretty tricky of me, huh? Sorry. Okay. If you know this one, then you count every multiple of that size. So there's 1 pi over 4, 2 pi over 4. Is that a half? 3 pi over 4. 4 pi over 4, which is 1. 5 pi over 4. 6 pi over 4, which we already did. 7 pi over 4. 8 pi over 4 is 2 pi. Can you do the radians pretty quick now? Maybe? Okay. Any questions? I'm going to fill the whole unit circle in just a second, but all right. I don't even want to put this ordered pair on here. I want you to know where to get this. If that's really confusing to me even, okay? If this is red right here, and this is a 30, 60, 90, you just told me that meant this was 1, square root of 3, and 2, right? So opposite over hypotenuse should be the sine, and adjacent over hypotenuse should be the cosine, right? Guys, let me tell you something else. 1/2 is smaller than square root of 3 over 2, yes? I know this is a 30, 60, 90. If you've been doing this at all, you know those are the two numbers you're going to get, right? So look at this little triangle. Did it go over further or up further? So this is over, and this is up. Does that make sense? You can remember which way it went? Now what's going to happen when I get up to the 60 up here is that's the same triangle, but this time I only went over a smaller amount and up further, right? All right, and in between here at this 45, 45, 90, I went over one and up one. Okay, and this is square root of 2. But what happens when you have to do sine over sine and cosine? If your triangle is 1, 1, and square root of 2, you get opposite over hypotenuse, which rationalizes to square root of 2 over 2 and square root of 2 over 2. Okay, both sine and cosine are the same. Everybody good? All right, now I want to talk about how you know to fill the rest of this in, guys. This blue triangle repeats where? Which is the next triangle right here? Is this one blue or red right here? It's blue, yes? It is this one flipped across this axis. Does everybody see that? Symmetry. So it's still left 1/2 and up square root of 3 over 2. What does the left part mean, though? I need to make it a negative. Okay. This triangle down here, I'm skipping to this one, is red, right? Matches up with this one. It went left square root of 3 over 2 and up 1/2. And the green one in between? Left square root of 2 over 2 and up square root of 2 over 2. All right, that symmetry continues. Down here, it's this one, yes? So this ordered pair is the same down here, 1/2 and square root of 3 over 2, except I went left and down, so they're both negative. That same one will be here. Okay, I went left 1/2. I'm sorry, I went right 1/2 and down square root of 3 over 2. Right, rather than keep talking about that, I want to fill this one in with you, okay? This is what the one on the quiz looks like. Hey, 0. I always divide pi over 6. Pi over 6. 2 pi over 6. Pi over 6. 5 pi over 6. Pi over 10 pi over 6. I'm skipping. 11 pi over 6. Okay, we good? Pairs. I went over further than I went up. This square is 3 and 1/2. This one's the same, but I talk about what the differential was. Okay, this one went over only 1/2. Why am I not getting up square root over 2? I don't have room. that the right blank or not? Right. All these. 1 squared is 2 over 2. 1 is 2 over 2. I forgot all the. I'm not even right spot. All right. This is the 45. Pi over 4 is there. 5 over 4 is 4. Okay. So I have all the ordered pairs except the quadrantals, right? Okay. So this I went over 1 and up 0, across 0 and up 1, left 1, up 0. This guy down here is 0 and up 1. So do I have everything? Okay. Better? You get the symmetry? Okay. I want to talk about how, okay guys, I want to talk about how you use that in the time that remains. So here's our unit circle, okay? We want to find this value. Do you have this? It says find the tangent at 5 pi over 3. Once you know the unit circle, you go to 5 pi over 3, which is here. And the tangent value is y over x. I wish I could convince everybody of this, but what happens when you divide that? You multiply by the reciprocal. So what happens? The denominators will always cancel out, okay? Because if I drew that triangle, I could label it square root of 3, 1, and 2, and you only need opposite over hypotenuse. So this should be negative square root of 3. As it's the y over the x, the denominators will go away. All right, 7 pi over 6, cosine. Is cosine x or y? X, so we write negative square root of 3 over 2. Now, 3 pi over 4 in a positive direction takes me to here. So guess what? Use your symmetry. Go this way, 3 pi over 4, and you're here, yes? Do you see what I'm talking about? You just went the opposite direction. Okay, what do I need to find there? Well, what's the cosine? The cosine is the x value, but I need to flip that over. What happens when I flip it over? I get 2 over this, which is negative square root of 2. That's painful. Okay, tangent at pi over 2. If I go up here to this ordered pair, what's tangent? You have to know. Y over x. Is that okay? Undefined. Okay, 15. 4 pi over 3 is right here. Cotangent is what? X over y. But what did I say about the denominators? So I get this. What is that going to reduce to? Square root of 3 over 3. Cosecant at negative 5 pi over 4. Well, positive 5 pi over 4 goes down into this quadrant, so negative, I'm back here. Cosecant is the reciprocal of which one? Sine, which is y, so I get this, which is just square root of 2, guys. Cosine at pi, right here. What's the cosine? X or y? X, so it's just negative 1. Cotangent at 270. Well, tangent is y over x, so cotangent is x over y, which is 0. Sine at 90, right back up here. The sine is just the y value, and you're done. Negative 60 is right here. Tangent is y over x. Okay? Work on page 251 tonight. We have some time to practice this again tomorrow.